Hey guys, sorry I'm not there again today. Really hopeful that I'll be there tomorrow. I know you're missing me. I'm missing you guys. So today we're really going to start learning more about circles. If you were absent yesterday, your students or your fellow students did an in-class assignment that you will not be able to make up until I'm there at school. So there's nothing for you to get out of the file folder. If you missed Monday, you need to get worksheet 1A and 1B out of the file folder and get those turned in. So today we're going to start learning about some arcs and angles within a circle. So some things that you should probably already know about circles is they have a center. So that point is equidistant from all the points on the circle. That distance from the center to the points on the circle is called the radius, and all radii of one circle are congruent to each other. So O to P and O to Q are the same distance. You should know it has an area, which is the inside space. Area is pi r squared. And you should know it has a distance around, which for other polygons, which this is not a polygon because it's not made of segments, but polygons we call that a perimeter. With circles we call it a circumference. And so the circumference of a circle is 2 pi r, or pi times diameter. So don't get circumference and area mixed up. Now we're going to start talking about arcs and angles, and there's different types of arcs and angles. The first angle we're going to learn is called a central angle. Well, mathematicians are not very creative in how we name things, but central angles have their vertex as the center of the circle. So any angle whose vertex is at the center of a circle is called a central angle. Now, when we start putting points on the circle itself, we're dividing that distance around into pieces, and those pieces are called arcs. And so, for instance, the distance between P and Q along that circle's edge is called an arc. We have different names for different types of arcs. So the first one you need to know is what's called a minor arc. Arc PQ, which this is the symbol for an arc, it looks like a little arc. Arc PQ is called a minor arc because it is less than 180 degrees. All the way around a circle is 360 degrees. So if you have a diameter, let's just extend that radius out here, then that diameter is separating the circle into two halves. And so from point P to this point, whatever we name it, I'll call it R, that would be halfway around the circle, so that's 180 degrees. From R to P would be the other 180 degrees. So obviously P to Q is less than 180 because it's a part of that half arc right there. So this again is called a minor arc. Another type of arc is called a major arc. A major arc would be like going from P to Q this way. Now when you name a major arc, you have to use 3 letters, because if you just use 2, we're going to think it's the shortest distance between those 2 points. So if I want to talk about from point P to point Q this way, I have to name a point along the way. So I'm going to have to use that point that I just made up there. So arc PRQ or arc QRP, the order's not important there, has to be bigger than 180 degrees because it went more than halfway around the circle, and that's called a major arc. Now, a term that you've probably heard before is called a semicircle. A semicircle is exactly 180 degrees. And so that would be, and you have to name those with 3 letters as well. So like arc PQR, from P to R going through Q is a semicircle because it is exactly halfway around the circle, so it's exactly 180 degrees. That's called a semicircle. So you can't name a semicircle with only 2 letters because you have to know which one you're talking about. So by using that middle letter, I know you're talking about going from P to R this way, not this way. So less than 180 is a minor, greater than 180 is major, and equal to 180 is a semicircle. You have to use 3 letters when naming a major arc or a semicircle, but you can only use 2 when naming a minor arc. Okay, so arcs are named for their endpoints. Besides the length of the arc, the measure is corresponding to the central angles measure. So each arc has a length and a degree measure. And we're going to be focusing on the degree measure with this lesson. So its length is a portion of the circumference, but that's not what we're talking about. We're talking about how much of the 360 degrees around the circle is that arc taking up. So let's look at our first relationship. We've already talked about this, minor arcs being less than 180 and naming with 2 letters, major arcs greater than 180, and semicircles exactly 180, and you have to use 3 letters to name those. The outside letters are the endpoints. The middle letter is just any point along that way. So if you were given another point here, I could have named that arc PTG, and that's exactly the same arc as PRG. Okay, but the endpoints have to be the outside letters. Okay, now let's start looking at the degree measure of the arc. The degree measure of a minor arc is equivalent to the degree measure of its central angle. So here in this circle, O is the center, and you can tell if it's giving your center if it gives you a specific point like that. So when you see these points here, you know that that's giving you the center. And we'll look at some that aren't centers later, and you'll understand what I'm talking about. When you see a defined point there, that's the center. So this is a central angle that's 60 degrees. So this minor arc is also 60 degrees. Minor arcs are equivalent to the degree measure of the central angle. Now, major arcs would be 360 degrees minus that central angle. So if you were trying to give me the measure of arc ACB, well, A to B is 60 degrees because it's a minor arc and it's equivalent to its central angle. So we would have to subtract 60 from 360 to find the major arc measure, which is 300. So of course those would add up to make the whole circle, which is 360. The degree measure of a semicircle is always 180, so it doesn't matter if you're going from B to C this way or B to C this way, it's half of the circle, so it is 180 degrees. Okay, so in circle P here, the circles are named by their center point, so that's how we name a circle there. Arcs AM and AT are examples of what are called adjacent arcs. We've used this word before. Adjacent just means next to, and they have to share something in common. So for example, adjacent angles, these 2 angles are adjacent angles because they share a side together. Okay, adjacent arcs have to share a common point, and you can tell by their name what point that is. It's point A. So since they share a point, those would be called adjacent arcs. Okay. The sum of the measure of 2 adjacent arcs is the measure of the arc formed by those 2. That's kind of a does statement. All that's saying is that the measure of arc PQ plus the measure of arc QR would equal the measure of arc PR all the way. You just add those parts. So all that means is part plus part is equal to the whole. And we've talked about that with segments and angles before. So let's look at an example here. When it says this is circle P, it's telling us P is the center. And so all the angles that have P as a vertex are called central angles. RT is a diameter, so we know it's separating that circle into 2 halves. We want to find the measure. That's what that little M stands for, is measure, just like with angles. We've looked at that before. What's the measure of angle ABC? That means the measure of arc RS, so it's wanting a degree answer, the measure of arc ST, and the measure of arc STR, and the measure of arc QS. So lots of answers we need to come up with. So the measure of arc RS, that's a minor arc, and so remember it's equivalent to its central angle degree. So RS, that arc is also 65 degrees. To find ST, we have to use the fact that RT is a diameter. So we know from R to T is halfway around the circle, so it has to be 180 degrees. So to find ST, I simply need to take 180 and subtract the 65 degrees from it. And so that tells me that the measure of arc ST is 115 degrees. The measure of arc STR, STR is going from S to R the long way. So that's the whole entire circle except for this 65-degree angle part right here. So to find the measure of arc STR, we're going to take 360, which is the full circle, and subtract away the part that we don't want, which is that 65 degrees. And so it is 295 degrees. And then finally, QS. Now, you have to understand, since it only has two letters, it's talking about the shortest distance, not the long way to get between those 2 points. So it has to be less than 180 degrees. So Q to S, the short way, is adding up those adjacent arcs. 75 plus 65 is 140 degrees. A term that you'll need to know is concentric circles. All concentric circles are circles that have the same center. And so it's like a dartboard. You have these different circles here, but the bullseye of the dartboard is the center of all of those circles. So those are concentric circles. These are all concentric circles because that point is the center of all of those circles. So that's what concentric means. So suppose that there are two concentric circles, and you have angle ASD that is forming two minor arcs. It's forming minor arc BC here and minor arc AD on this circle. Are the two arcs congruent? So this is important to understand. When you're talking about congruency, you're talking about length. But when we're finding its degree measure, we're not talking about its length. The degree measure is equivalent to the central angle measure. So the measure of arc BC and the measure of arc AD are both 60 degrees because that's the central angle that's forming those arcs. But that does not mean that they are congruent. Congruent means they're the same length. Well, they're not the same length. It's obvious that from point B to point C is a shorter distance than from A to D. So they are not congruent even though they have the same degree measure. So it's really important that you understand that those are two totally different things. If you want a degree measure, it's going to ask you what the measure of the arc is. If it's asking you for the length, it's just going to say arc BC is equal to what? Okay, so this means degree, this means length. So angles can have the same degree measure, not angles, arcs. Arcs can have the same degree measure and not be the same length. So no, they're not congruent, even though they have the same degree measure. The next type of angle that we're going to look at is called an inscribed angle. Now, central angles have the vertex at the center, and that is always what you want to be focused on, is where the vertex of the angle is. With inscribed angles, the vertex is not going to be at the center, it's going to be at a point on the circle. So for instance, angle LKJ is a inscribed angle because its vertex, which is always the middle letter when you name it, is on the circle. If it's at the center, it's a central angle. If it's on the circle, it's an inscribed angle. Okay, so it has a relationship also to the arc that it forms. So if you follow the sides of the angle, you go to point L here and point J here. So the arc that it intercepts is this arc right here, arc LJ. And there's a relationship between the angle and the arc, but they're not equal like it is with the central angle. So I can draw the central angle here. Angle LCJ, C is the center of the circle. This is a central angle. Central angles are equal to their arc. So this arc has the same degree measure as that angle. But this angle is not the same degree measure. You can see, obviously, it's smaller. So it has a different relationship. And here it is. The degree measure of an inscribed angle is 1/2 of the arc that it intercepts. So angle PQR has a degree measure that is half the degree measure of the arc it forms, which is from point P to point R. So for example, if from point P to point R is 120 degrees, then the inscribed angle is half of that. It's 60 degrees. And so those are two relationships you need to keep separate. Central angles are equal to the arc, and inscribed angles are half of the arc. So let's look at an example. Here we want to find the measure of angle FGH. The vertex of the angle is a point on the circle, so that's called an inscribed angle. So the measure of angle FGH is going to be half of the measure of the arc it forms. Follow the sides to point F and point H. This is the arc that it is half of. Half of the arc, measure of arc FH. Well, it tells us the measure of arc FH is 58 degrees. So the measure of angle FGH is simply half of 58, which is 29 degrees. Now be careful, if you're given the angle measure, you're going to have to double it to get the arc. But it's always the angle is half the arc. The next example gives us a good relationship that we need to understand. It's telling us the name of the circle is A, and so A is the center. We don't have any angles going as the vertex with A, so we don't have any central angles. It tells us the measure of angle 1 is an expression, 2x, and the measure of angle 2 is x plus 14, also another expression. And we want to find the value of x. Well, both of these angles, angles 1 and angle 2, have their vertices on the circle. So they are both inscribed angles. And so we know inscribed angles are half of their arcs. So the arc that is formed by angle 1 goes from point L to point W. So it's arc LW. So measure of angle 1 is half of the measure of arc LW. When we follow the sides of angle 2, we also go to point L and point W. So it is also half of arc, the measure of arc LW. So if they are both half of the same arc measure, then we know they have to be equal to each other. So angle 1, the measure, has to equal the measure of angle 2, since they're both half of the same degree of the arc. So all we have to do to solve for x is set 2x equal to x plus 14. So we know that's called variables on both sides. We want our variables on the same side, so we can subtract x from both sides and get x equals 14. That's all we had to find, but now that we know the value of x, we could also tell what the angle measures are. The measure of angle 1 is 2 times x. 2 times 14 is 28 degrees. Well, 14 plus 14 is also 28 degrees. So now we can find what the measure of arc LW is. Since that angle is half the arc, we have to double that to get the measure of the arc. So the arc would have to be 56 degrees. That's half of this. But the question just said find the value of x, so x equals 14. Okay, in the next example, it says suppose that the angle MTD is inscribed in circle C. When it says it's inscribed, it's just telling you that the vertex is on the circle, which we can see. T is on the circle. It's intercepting a semicircle. MYD is a semicircle. If MYD is a semicircle, then this segment connecting points M to D has to be a diameter. And so we remember semicircles are half of the 360 degrees. So we know that the measure of the arc MYD, that semicircle, is exactly 180 degrees. Well, since inscribed angles are half of their arcs, we know that angle MTD is half of that arc. Half of 180 is 90 degrees. So it is a right angle. This relationship is a theorem that says if you have an inscribed angle intercepting a semicircle, it's always going to be a right angle. And you know that because it's half of the arc. Half of 180 is 90 degrees. Another theorem that you'll need to know is that in a circle or two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. chord is a word that you should have reviewed on Monday with your vocabulary. Chords must be segments whose endpoints are both on the circle. So AD is a chord, BC is a chord because the endpoints are on the circle. If and only if statements we've talked about before are called biconditional. It means the statement goes both ways. It means if you have two minor arcs that are congruent, if these arcs are the same length, then that means their chords have to be congruent or the same length. And vice versa. If the chords are congruent, then those arcs have to be congruent. Remember, congruence is talking about length, okay, not degree measure. So we've already talked about two arcs can have the same degree measure and not be congruent. But if you have two chords that are congruent and they're in the same circle, then they have to be the same degree measure. Okay, so make sure that you keep that straight in your mind. So we talked about here, we can have two arcs that are the same degree measure that are not the same length. But if you have two arcs that are the same degree measure in the same circle, so let's say this arc from B to, I'll call this E, if this was also 60 degrees, since these are 60-degree arcs of the same circle, they would have to be the same length. So they would have to be congruent as well. Okay, so that's all there is to this lesson today. Your homework is worksheet 2. Remember that two arcs can have the same measure, which remember is in degrees, but not be congruent. Okay, so Marcella is the one that's correct in this, not Dexter. Dexter says that if two arcs have the same measure, then they're congruent. And that's not true. We've looked at that with the concentric circles. So we know we can have two circles with the same center, and if we look at the degree measures of these arcs, they would be the same degree measure because there's the same central angle that's forming them. But they're not the same length. This one's shorter than that one. I'm guessing on the homework that these two may not be able to be read very well. So if so, you might want to pause the video here just to make sure you can read that really well. On this one, A is the center and LM is a diameter. This one, you're not given the center. Okay, so don't try to treat any of that as central angles. So I hope to see you tomorrow.